For our last section in modeling geometric figures, we're going to be looking at something called angle relationships. There are lots of different types of angles. We know about obtuse angles, we know about acute angles, we know about right angles, but there are relationships between angles that we also need to talk about. So the first one we're going to look at this graphic organizer here to look at our different types of relationships. The first one here is the top middle, and these are vertical angles. Vertical angles are two angles across from each other on intersecting lines, and they are always congruent. Keep in mind, congruent means equal or the same. Okay, so if I were to draw a set of vertical angles, I would draw two lines that intersect. I'm going to draw these as arrows because these lines go on forever. And I'm going to label these 1 and 2 and 3 and 4. So when I have vertical angles, I'm looking at angles that are directly across from each other. So here I can say that angle 1 is the same as angle 2, and angle 3 is the same as angle 4. So if I ever give you a vertical angle relationship and I ask you what the angle is, just look at the angle across from it and you should immediately know. Coming down here to the left, we have adjacent angles. Adjacent angles are just two angles that are next to each other. They share a common side. So that would look like this. So here's an angle, here's angle 2. They're both next to each other. They share this side right here. That's what makes it adjacent, is that they share a ray or a side. Okay, working counterclockwise, down at the bottom left here, let's look at complementary angles. And they are any two angles whose sum is 90 degrees. So for example, you could have an angle here that is 70 degrees, and you could have an angle here which is 20 degrees. If I add those two angles together, they equal 90 degrees. You'll probably see most complementary angles like this on a right angle. And we have two angles here, one is 30, the other is 60. They add up to 90 degrees. We call that complementary. Okay? To the right, we have supplementary angles, and they're just two angles that add up to 180. And it could be more than two angles. It could be 2, 3, 4 angles that add up to 180. We'll certainly see those. But for the most part, they're just two angles that add up to 180. So to draw a visual of that, we could have an angle here that's 120 degrees. And we could have an angle here which is 60 degrees. 120 plus 60 is 180. And then a linear pair, which we won't see as much, but just so you know what it means, are two angles that are adjacent and supplementary. They're on a straight line. Sometimes you'll see these called straight angles. Sometimes they're called straight angles, and that just looks like this. On a straight line, and a ray that comes in the middle. Here's angle 1, here's angle 2. We just say that angle 1 plus angle 2 equals 180 degrees. Okay, so let's talk about our notes. So on the other page of this, we have our actual angle relationship. So let's apply the vocabulary that we just talked about. So our essential question here is, how can I use angle relationships to solve problems? Keep that in mind as we go through this entire section here. I have this diagram on the left here, and it looks like a lot, but we're just gonna kind of dissect it all, okay? I want you to use this diagram to identify a pair of vertical angles. Now remember, we said that vertical angles are two angles that are directly across from each other. So we could look here. I see that these two lines, these two straight lines, intersect each other, which means this angle and this angle are going to be the same. So we'll say that angle BFA, this angle right here, and I'm kind of making with a thicker line, we'll call that angle BFA is a vertical or equal to angle DFE. Okay, you could also say that these two angles here are vertical, AFE and BFD. AFE and BFD. Okay, we want to also look at B here, a pair of adjacent angles, and they're just any angles that are next to each other. You could choose anything here. I'm going to pick BFA, and actually I'll erase this so you could see it better. I'm going to pick BFA and AFE. Notice I'm not putting an equal sign here because adjacent angles are not necessarily equal to each other. They can be, but in this case they're not. I want you to think of another set of adjacent angles here. Pause for a second and write one of those in. Okay, let's move on to C. A pair of supplementary angles. Remember, those are angles that add up to 180 degrees. You're going to find supplementary angles on a straight line. Now, coincidentally, the same answer that I put for adjacent angles is also a good answer here. Angle BFA and angle AFE are supplementary. They're on this straight line. Okay, they're a linear pair as well. They share this side right here. Okay, pause here and see if you can find another set of supplementary angles. And finally, let's look at D. A pair of complementary angles. So two angles that add up to 90 degrees. Now, I know that right here, I have a right angle. Angle CFD. Well, this angle is on this straight line, which means this right here is going to be a right angle too, because I know that 90 and 90 make 180. So this is what I want you to start thinking about. Think about these relationships here. You have three angles here. This one right here, AFB, BFC, and CFD, all on a straight line. Those would be supplementary. But if we just kind of ignore that line right here, the BF line here, we see that this right angle is on a straight line. This is 90 degrees, which means that whatever this is right here is also 90 degrees. So angles BFC and angle BFA, so right here and here, this angle right here, plus this angle right here, angle BFA, is going to equal 90 degrees as well. Okay, so we've practiced identifying different angle relationships. Let's explore complementary angles for a moment. And we know that complementary angles add up to 90 degrees. I want you to think about also how we can use equations to find angle measurements. I've included a GeoGebra link right here that you can go to. If you go on Edmodo and go to the digital version of this document, you can click on that. And if we look at that, you can use this pink slider right here to slide these angles. Okay, if I slide to the left, the pink one closes, the blue one opens up, and vice versa. And just to test that that's complementary, just slide this black slider. You see that they come over here and they line up on this 90-degree angle. And this is just a nice other visual to see that these two angles, when they're complementary, will add up to 90 degrees. So here I want to find the measure of zxy. Now we know that on here, these two angles will add up to 90 degrees. So you could easily figure out what zxy is just by doing 90 minus 35, and that equals, see, 55 degrees. Okay. However, sometimes I'm going to ask you to find the value of x, and I want you to use an equation to do this. So let's add up these two angles. I have 35 plus 4x plus 7, and that's just these two angles right here, wxy and zxy. And we know if we add those two angles together, they equal 90 degrees. So let's solve this equation by simplifying the left side first. We have 4x, we have 35 and 7, which make 42, equals 90, and we'll just solve. (4x) equals 48, so x equals 12. Now if I ask you what x equals, you would just stop there and tell me x equals 12. If I asked you to find the measure of the angle, you would just take that x and plug it back into the expression here. So we know that that angle is 4x plus 7, so just replace the x with 12, and you get 55 degrees. Pause here and try to find the measure of angle M and Q with an equation. Okay, to check, to make sure to see what our answer would be, we know that a complementary angle will add up to 90. So if we just subtract the 58 from 90, that gives us an angle measurement of 32. That's the answer that we are going for here. So let's create our equation. I can add angle M and Q, which is 3x minus 13, and angle Q and P, which is 58. And I know that those two angles added together equal 90. So I'll go ahead and combine my like terms. That gives me 3x plus 45 equals 90. Subtract 45 on both sides. And so x would equal 15. So if I asked you what x would equal in this case, you would give me 15. If I asked you the measurement of the angle, you would go in and you would replace x in the expression 3x minus 13 with 15. So 3 times 15 minus 13 is 45 minus 13, or 32. Let's move on and talk about supplementary angles. Supplementary angles are, like we said, two angles that are going to add to 180 degrees. So let's look at our GeoGebra link, just to explore that for a moment. Oops. Okay. So I have two angles here, a pink one and a blue one, and as I move this slider around, both those angles change. And if I slide them and combine them together, I see that they line up on a straight line. So that's one reason why we call them straight angles, or a linear pair, because they are two angles that are on a line. Okay? These are both the same two angles. They come together to create a straight line. So in our first example, I want to find the measure of angle JML, which is this right here. Okay, so the answer we're going for here is, if I know that this angle is 54, LMN, I know that's 54. I could just subtract that from 180. And that gives me 126 degrees. So that's the answer we're going for here. But we are going to write an equation. One, because sometimes I will ask you to look for x, or whatever the variable is. And sometimes I really need you to practice those skills that we had when we wrote and solved equations. So let's look here. We have these two angles added together, make 180 degrees. So 3x plus 54 equals 180. Subtract both sides by 54. You're left with 3x equals 126, or x equals 42. And if I want to make sure that that's value of x is correct, all I have to do is just plug that into my expression here, my single variable term here, 3x. 3 times 42 does equal 126 degrees. So that is correct. Pause the video and I want you to try to find the measure of angle EHF on the second example here. All right, so just to figure out what our answer should be, we know that this angle is 48 degrees. So if I subtract that from 180, I'm going to get 134. Let me just double check my math real quick. Yeah, 134. So that's the answer we're going for here. So when you wrote your equation, you remember you're adding these two angles together, and they equal 180 degrees. 2x plus 48 equals 180. We'll solve this two-step equation. Subtract 48 on both sides. Gives me 2x equals 134, and x equals 67. And all I need to do is come back to my original expression. Oh, and I see I already made a mistake. This actually was 132 because I wrote 46 there. So let me just change that real quick. My apologies. There we go. I thought my math was right. Okay, so x actually equals 66. So let's go ahead and plug that back into the original expression. 2x. 2 times 66 is 132. And that's our correct answer. Okay, and finally, I want to take a look at vertical angles. So if we go to our GeoGebra link here, we have vertical angles here. And I'm just going to check the boxes here to show the first pair. And if we move our sliders around, we see that those angles are the exact same. You can do that too. You can see that these two angles are the exact same. Okay, we can look at another pair and see, okay, these two angles are exactly the same. They are directly across from each other, and they are exactly the same. So we want to find the measure here of FEG, which is right here. Actually, that is FGE. FGE. Okay, we know that it's 2x, but we want to find the actual measurement of it. So think about your vertical angles. We know that angles across from each other are equal. So if this FGE is 2x, that actually means that BGC is also 2x. If CGD is 50, that means AGF is also 50. And if BGA is 30, that means DGE is also 30. So we can use any of these angles to really help us here. Okay, so I know that, let's say here I have these angles right here on a straight line. And think about it for a second. All angles that are on a straight line are going to add to 180. So I could add up these three angles right here. So 50 plus 30 plus 2x equals 180. So we're really kind of tying in examples here of vertical angles and supplementary angles together. And I can go ahead and combine my like terms. That gives me 2x plus 80 equals 180. And if we subtract both sides by 80, that leaves us with 2x equals 100. X equals 50. So that does tell us that this angle right here is 2x. This one is also 2x. And we know that 2x tells us right here 2x is equal to 100. So that angle measure is 100 degrees. If you have any other questions on this, come see me in class, and have a great night.